Hi, everyone. A few of you asked for some recordings of lessons, so I thought I would do a couple starting from chapter 5. If you need any earlier ones, I can, but I figured most of you were done with the earlier chapters. So I'm just going to go through this quickly. If you're taking notes while you're going through the PowerPoint, you can pause and write things down and then continue. So if this helps you, you can sure use these, but I'll try to keep it short so you don't have to spend a lot of time watching them. So this chapter is on the skeletal system. And one of the big things, the coolest things about the skeletal system is that bone is considered an organ. Like one bone is considered an organ because it's made of tissue. So anytime you have lots of tissues, they make up an organ. And it has a really interesting structure. It's made of living cells, which some people don't realize. And those cells are called osteoblasts. Those are the cells that build bone. And then you also have cells called osteoclasts that break down bone. Osteocytes is another name for bone cells. So you'll see some of those terms pop up, and anytime you see osteo, that means bone. These cells can make different things when, like, they start out as cartilage and then they secrete, or they absorb calcium, and that's what makes them bone. So they're pretty neat cells. There's two main types of bone. You have compact bone and spongy bone. You've probably heard of those. If you've ever broken open a chicken bone, like a drumstick bone, you've probably seen the compact bone and the spongy bone. You usually see that in a long bone. The compact bone's the dense part, and then the spongy bone has tends to have bone marrow inside. And here's a cutaway of that. So you can see a little bit of bone marrow in the spongy bone, and then it also has some in that cavity of the long bone. I hope you can see my mouse. And then this top picture shows some bone cells with blood vessels feeding it. So this really shows you that bones are living, and they have blood vessels and nerve endings, and that's why you feel it when you break a bone. So bone develops with cartilage when you're still a baby, like when you're an embryo, a fetus, I should say. Your bones are mostly cartilage, and then the calcium gets added to them and it becomes bone. And this is how bones are growing. So you can see the embryo there. This looks like a femur probably. And then as it gets longer, it gets more vascularized. You have more blood flow. You kind of tend to form like the two ends, and then you have the middle part. So all the while you have osteoblasts, which are building bone. Those are the cells that build bone. And then you have osteoclasts, which are the cells that destroy bone, and they're remodeling. They're trimming away and adding to make your adult bone. Okay, so here's the steps. All right. So bone's constantly being remodeled as you use your bone. As you use your body, your bones are being remodeled. If you break a bone, they're going to heal and then become remodeled, and you might notice like a bump on the bone where your osteoblasts, your building cells, kind of overdid it, and then your osteoclasts will trim that away, but sometimes it's not perfect. You can still see the bulge. And then as you're using your body in different ways, if you're an athlete or whatever, your bones will start to remodel for that purpose, and your bones are going to grow when you use them. So the more exercise you do as like a kid and an adult, the more your bones are going to grow. And if you're a woman, as you get older, you're at more risk for osteoporosis because you're exposed to estrogen. So the more you exercise and use your bones, the more they're going to grow and strengthen. Okay, so you probably heard this. We have 206 bones. And then we have these ligaments and tendons. Ligaments connect bone to bone. Tendons connect muscles to bones. So here's some of your different bones. These are the functions of your bones that you can go through. So we use bones for movement, support of your muscles mostly, and then protection of your organs, like in your torso. We have a lot of really important organs really concentrated in one area, and so our ribs really protect that. They store minerals, so that's where our bones store calcium. And phosphorus. Our body needs calcium. Our muscles need calcium to contract. So this is where we put leftover calcium. But if you are not eating enough calcium, your blood is going to steal it from your bones. And you might have a blood test that says that your calcium's okay, but it turns out that it's actually stealing from the bone. So we need to make sure that we're consuming enough calcium and our bones are strong. And then also that's where our blood cells are made in the bone marrow. So here's all the different bones that they have labeled here. You probably have learned some of these. So it's a good idea to go through and become familiar with some of these names. Oh, one last thing. The axial skeleton, it's not really shown very well here, but that's the part of the skeleton with the skull and the vertebrae and the ribs. And then your appendicular skeleton is all your appendages. So that's what these two terms are at the top. So for your axial skeleton, you've got your skull, facial bones, backbone. Here are some bones of your skull. And they're broken up into different parts. And these also are going to be similar to the parts of your brain. So like frontal lobe and temporal lobe, and all of those, occipital lobe and parietal lobe. And then you have some of these bones of your face that have different functions. And you might notice some little nooks and crannies on these bones. And a lot of those are either to connect muscles or for blood vessels to come in and out of. So every little part of your body, every structure of your body has a purpose. There's a reason that it's structured the way it is. And then here's another view. Your sinuses are housed in your skull, so your cranium has spaces to house your sinuses. And then we look at your appendicular skeleton. So that's your limbs, upper chest, shoulders, pelvis, pectoral girdle, and your pelvic girdle, and then your fingers and legs. So there is your appendicular skeleton. Those are your appendages. And then for axial, you can remember that as the axis. And then joints, there's lots of different kinds of joints. And I'm sure that you've heard of them. Maybe some of yours are getting creaky or you've injured them. The joints that we normally think of that are the most flexible, that we use a lot, are called synovial joints, but there are other types of joints. So like hinge joints and ball and socket joints are two examples that you've probably heard of. So you have a ball and socket joint in your pelvis and in your shoulder, and then hinge joints in your elbow and your knee. And then there's also cartilaginous joints and fibrous joints. So those are the joints that don't move as much. Like cartilaginous joints are what are in your vertebral column, and then fibrous joints are like in your teeth, to hold your teeth in. So here's some examples of joints. That's a knee joint. The knee is pretty complicated. And if you injure it, you probably have major surgery. I had to have ACL surgery. And all of these little ligaments, these are ligaments because they connect bone to bone. They're all very important. They're purposeful, and they make sure that you're able to walk and bend your knee and support your weight. And so if one little ligament is even just barely torn, it can affect your ability to walk. These are some different movements that we can make, and their names. So you can go through each of these, try it, see what it means, like try it out, and maybe see if your body has the full range of motion that it should. Here's some other ones, some other terms that you can try. And then here are some disorders of the skeleton. So one is osteoporosis, which I mentioned earlier. It's more common in women. And that's because we lose calcium, we lose mass out of our bones as we get older. So exercise helps with that because your bone growth is stimulated by exercise. And then eating calcium too. And then osteoarthritis is when, from overuse, your joints become worn away, and then your bone starts rubbing on bone. So you've probably heard of both of those. Rheumatoid arthritis is another type of arthritis where the immune system attacks the joints. And then carpal tunnel, you probably heard of, also from repetitive motion, and people typically have to get surgery. And so this is a picture of osteoporosis. Osteo means bone and porosis means pores. So you can see that there's little holes in this, and that's going to make the bone really brittle, and it'll be able to break easily. So somebody who has osteoporosis might break their hip or something. And the neat thing about this other picture is it shows the bone's structure, and it kind of has like cross beams, like in a steel building that you might see. The bone typically isn't like solid because it would be a lot heavier. And so this is a way to keep it really strong, but also make it light. So And then this looks like a knee replacement. That's the patella front and those things they put in there. Here's some other things that can happen that you probably heard about. So sprains, that's when you have a tear in your ligament or tendon. Dislocation is when the joint is out of place. A fracture, there's different types of fractures. There can be genetic diseases that affect your skeletal system. You can get infections in your bones, and you can also get bone cancer. So here are different fractures. And this is a bone disease. So the book probably has specifically what that disease is. Okay, so now we have homeostasis in the skeletal system. Homeostasis means keeping all the levels the same, all in balance. Your levels in your body, like your water, your salt, your pH, temperature, they like to swing out of place when environment changes, and your body works really hard to keep them in an even keel. So your skeletal system's role in that is keeping a calcium reservoir. Calcium is really important, not just in your bones, but for a lot of other things in your body. And then also to support, help protect, and move body parts. So that's how it works with homeostasis. Your skeletal system also interacts with the integumentary system, supports skin and muscles. Muscular system, it provides levers so your muscles have something to move, like your muscles are physically moving the bones. And then your muscles also use the calcium to contract. Like that's where they get the calcium to do a contraction. Your muscles cannot contract without calcium. And your digestive system also, when you eat calcium, your digestive system brings that in and allows your blood to absorb it, and then it goes to your bones for storage. For cardiovascular system and the blood, we also use calcium for heart contractions. The heart's also a muscle. And I think it uses calcium more so than skeletal muscles. And then in your bone marrow, the way that another way that cardiovascular system interacts with the skeletal system is that you make blood cells in your bone marrow, and then you make white blood cells in your bone marrow. So there's the interaction between your immune system and your lymphatic system. And then it also interacts with your respiratory system because your lungs are protected by bone. And then I would also argue that your bone cells are provided oxygen by your lungs because your bone cells are living and they need oxygen. Urinary system, your bones protect your bladder and partially your kidneys and your back. And then your nervous system is protected by the skull. And then nerve impulses also require calcium. You cannot have a nerve impulse without calcium. Your sensory system also interacts with skeletal because you need calcium for your nerve impulses. Endocrine system even. So the fact that your body requires calcium, that's endocrine system's territory. And so maintaining those levels is the job of the endocrine system, those calcium levels. And then for reproductive system, there's a couple ways, especially for females. So our pelvis protects all those organs in there for females. And then also the calcium that we feed our babies with comes from our bones too. Okay, so here's a summary of appendicular and axial for you, and that is the end of it. So hopefully that was helpful to kind of listen to and walk through, and I will share some other videos that you can use if they're helpful. All right, I'll see you later.